We've got 4 talks in this session. The first one is a full paper, so it's a bit longer, and we have a discussant who's Andreas Lerner as well. So it's my pleasure to introduce Marco, who's going to talk about generic diff3.
Hello everyone, I'm Marco Bassena, and today I'm going to talk about generic diff for algebraic data types. So this was work from my master thesis at Utrecht University, and I wrap up this work and finished off at Chalmers, where I'm working now. So, well, today we are never alone. We always work with other people, and normally to do that we use GitHub and repositories like this. So normally we start with the same version of a file, and then we work, and at some point we want to somehow combine the changes that each one of us made. And well, this is the essence of this work. Is about how to make, so we already do this, but we want to, somehow we will see this is a little bit unsatisfactory. So let's take a look into this. Well, even though we normally do use GitHub and so on for source code, sometimes we also work on different sort of data, like structured data, like a table. So normally what happens is that we start with the same one, and suddenly we have 2 different persons working in parallel on the same table. And one, for instance, adds a column of zeros, and the other one just changes a couple of values. Well, easy. Now we just want to merge them, right? And, well, what we get is exactly what you would expect, because, well, these are sort of independent changes, right? So what we get is this nice table in which we have our column of zeros, and it changes the orange ones that we see on your right. Well, but this is, unfortunately, just theory. Because when we actually try to do this with Git, Mercurial, Subversion, we get conflicts. So why is this? This is very unsatisfactory. So this is not a toy example. So this is actually what happens when we do this with this algorithm diff3 that is used by the main version control system nowadays. Well, the problem with diff3 is that this is a line-based algorithm, which means that even though we have a table, and the table is made of rows, what you actually see is all the time is just lines. So our nice table is actually stored in a file as a CSV file, which is just made out of made of numbers separated by commas and new lines. So each row corresponds to a line in our file, and each cell is separated by commas. And what is even worse is that when we actually when this diff3 algorithm tries to detect changes to to merge them afterwards, it has to approximate our changes. So we might have changed only one cell, but what happens is that the whole line seems to have changed to this line-based algorithm. So this is problematic, because then what happens is that when we try to merge these 2 tables with the original one in the middle, what happens is that these tables are merged row by row, which means line by line. And in the first case, well, we can actually merge these 2 because there's only one version that changed, and this is fine. But what happens for the other 2? Well, here, what color should we pick? And for this one is the same. Well, there's no safe choice here. We could choose blue, but then what about the changes made in the right one? Or we could choose the other, but then we would back out the other one. And somehow we still want to converge at some point. So what happens is that this diff3 algorithm generates a conflict. And this is then up to the users to fix them. The problem, though, is that as you can imagine, as you guessed from the first slide, we are actually able to merge these 2 tables. But the real problem is that this diff3 algorithm is only as a fixed precision. And this is the reason why, in the end, we have this spurious conflict. So let's imagine for a second that diff3 knew about rows and knew about cells. Well, then we would just, as you can see here, I'm just plotting one row, just for the sake of the example. And in the second and the third version, I have the dashed box, because if we are cell aware, then we know that here there could be an actual cell. And when we try to merge the first column, then we somehow know that there could be a cell there, and therefore we have these boxes. And in this case, as you see, only one version is different, and that's why here we could merge that. And here in the second column, all the values are the same, and so, well, this is an easy one. There is 4, and here we got the same, and here we only one change, and therefore we can put 9. And somehow we didn't really trigger a conflict. So if we knew about cells, we could actually merge this row, and as we merge this one, we could merge the third row. And so why still at the same time this diff3 gives us conflict? This is because of the line-based component. So this is disappointing, and this is what this work is tries to address. While diff3 only works with text files, we will work with algebraic data types. And furthermore, we will use generic algorithms, because we don't want to re-implement this for every single sort of structured data that we could happen to work with. And the third disadvantage of diff3 is that this is a sort of a fixed precision, line-based, whereas with the algebraic data type approach, we can actually have a much more refined precision. And this will actually matter, as we will see in the following. Lastly, diff3 is very, very much used. So it's used in the main version control system. However, it's not really been formally defined, or there's been one paper recently where they did. And as it turns out, there's just a lot of misconceptions about diff3. Things like, well, if we change independent lines, then we won't get a conflict. Well, that turns out to be a lie, and there's a paper who actually finds this about. And what I did in this work instead is that I've formalized the semantics of this diff3 algorithm. Well, the universe that I'm going to use consists of well-typed trees. So I won't show any actual code, but the idea is that every node is typed and in such a way that the constructor of the algebraic data type that goes there can take a fixed number of children, exactly those of the type that it would expect. So here we have a row 4, 5, 6, and this is the first cons has 2 children, and the first one is an int because the first field of the cons is an int, and what we have on the right is another tree, which is the rest of the list. And with this much more refined representation, we can actually see more precisely the changes that we have in our rows. Now, the work that I did is not bound to any specific diff algorithm. At the same time, we use diff to somehow create one of these edit scripts, which contain edits that transform one input value into the other. And the only specification in the world that I need for this to work is just this sort of sanity check that actually, if we get an edit script out of a diff and then we apply with this function patch to the original object, then we get the second, the target object. Of course, this is using a generic representation. So actually, the algorithms just only need to work with this tree, well-typed tree representation. But let's take a look about how edit scripts are made. So while diff3, Unix diff3 use insert, delete, and copy, we will use mappings. So this is the source node and this is the target node, and I will use in the following this shortcut to represent the identity edit, which doesn't change anything at all. Now, a diff, suitable diff for our algorithm, we could find for this example this sort of edit script, where we map the first cons to the second one, 5 to 5, copy cons, 6 to 9. So this is an actual change, an update that happened, and the last one is just another identity. So what these edit scripts are doing is that they are somehow embedding the nodes of the source tree, the one on the left, into the target tree, the one on the right. And we will use this diff to generate edit script that then we will merge. And from merging this edit script and then patching with the source object, we will get out the merge object that we were looking for. Now, how do we merge edit script? Well, as it turns out, it's just by merging by merging edits in a pointwise manner. So what we have here is two align edits. So these are aligned because they have the same source value. And so this is very important. And with dependent types, we can actually enforce this sort of property. And what should this operator do? Well, it either finds a conflict between these two edits that may not be merged together, or finds an edit that actually merges the two of them and that combines the change of both of them. And look at on the right, the source is fixed because these two edits are aligned, and therefore the only value that we have to determine is the target one, the target node. Now, as I said, I formalized the semantics, and I didn't really invent anything. What I did is just trying to formalize in Agda the merge semantics of the three-way merge, which says that for every three nodes, either we can merge them in this way by changing, when the left one is an identity, then we take the right one because that's the only one that makes a change. And this is the converse one, the dual. When the right one is identity, then we will of course take the blue one, the only change. And when the two edits happen to make exactly the same change, then we have only one choice there to merge them. And so interesting, as I said, we have identity, left identity. The identity edit is the left identity of this merge operator, and the right identity, and this operator is also idempotent because if we apply the same edit, we get exactly that one. Now, let's turn to the conflict semantics, which is defined as only to edit, the constraints that we need are these inequalities. And the reason why we need those is because otherwise we could actually merge these two. So this is very powerful because we have only a handful of rules, and we have defined the merge and conflict semantics of a merging algorithm in essence. Then what we need to do to actually merge things is the diff3 algorithm does, where we just compute the diff from the source to one version, from the source to the other version, and then we apply this merge operator pointwise. Now, there's things that I haven't showed you yet. For instance, what happens when there is no source node for some from some node in the target? Well, the way this is handled is that we just introduce a sort of dummy, empty node, which has the purpose to exactly represent this sort of edit. So now we have edits that are defined over values that may be there or not. We say a maybe node. So then we have 4 kinds of edit: either a node operation, delete when we don't have any target node, insert when we don't have any source, and update. And note that the only edits that can be identity edits are the no operation and the update. Now, when we have insert, we have somehow a problem in diff3 that alignment might not be satisfied anymore. So in this case, if we try to merge these two edit scripts, well, we would run into problems because they don't have the same source. And this was a precondition of our merge operator. And the same goes for the second one. How can we fix this? Well, we can restore that by introducing no operation. And the important part is that no operations are totally fine, because as I said, these are identity edits, so they won't actually trigger any conflict. Furthermore, since they are no operation, they don't really change anything in the source or in the target object. So they are really just a matter of aligning the two scripts together. So now that these two edit scripts are aligned, we can just merge them and get what we would actually expect. Now, what I'm going to show you now is somehow what I hope to gain from this talk is some input from you, because when we worked on this, we actually found out that there is yet one more way now in a strongly typed word for merge to fail. That is not the normal conflict that we have like with diff3, but is some kind of ill-typed edit script. So the problem with this one is that it doesn't contain any actual conflict, not like trying to have the opposite target nodes for the same source nodes, but at the same time, it doesn't really produce a well-typed tree, because, well, this is not a well-typed application. It doesn't, the nil constructor doesn't take a list, and yet this is the kind of tree that we would get out of this edit script. So it's very tricky and very counterintuitive, because we started with two well-typed scripts that would actually generate well-typed object, well-typed list, and yet even though we don't find any actual conflict at the value level, at the type level something goes wrong. And well, I would say that the problem is that we are somehow just joining and merging point-wise, but it's I really hope that someone could come up with some good ideas about better ways to merge edit script. And with this, I just want to wrap up. Remind you that today I showed you a generic diff3 algorithm, which is fine-grained and which you can use to diff and merge changes made to structured data. And this algorithm has been formalized in Agda, and I've studied semantics, merge and conflict semantics. Thank you very much.
Okay. So I have a discussion.
Yeah, I'll try not to speak too much and leave room for other questions. So first of all, I want to thank you for the nice talk, and I must say I'm very happy to see this work picked up. So I've been working on a generic diff algorithm together with Ilko Lemsink and Sean Leather, I think 6-7 years ago. It's quite a long time, and this work is based on that, and I'm very happy that this is continued. And the diff has seen a number of interesting examples over the years. So, for example, defining differences of musical harmony, or more recently, there seems to be renewed interest because of virtual DOM, people have started diffing all sorts of things. So that seems to have inspired quite a number of people to look at this. But now diff3 is particularly interesting to me because it brings conflicts into the picture, and that's an interesting point. And I want to discuss a little bit the conflicts, although you've also already hinted at the alignment. So these are in a way the two the two interesting points I wanted to bring up. So let's perhaps start with the alignment, because you've already talked about that a bit. Mm-hmm. So actually, that seems to be really subtle, and you admit that in the paper, that how you choose to align two sequences can have an effect on whether you get merge conflicts or not. And actually, that can be wrong in both ways, I think. In practice, you might get too many conflicts yet again, but you might also get too few conflicts. So if you imagine you have a list that contains only 1, and I change the 1 to a 2 in one version, and I change the 1 to 2 1s in another version, there is a valid merge, right? By saying I produce a list 2 1, but there is also a valid merge that produces the list 1 2, and I would rather not have the diff algorithm make that decision for me. I actually want to have a conflict here, and I think you're currently not guaranteeing that probably. So actually finding the right way to align things is really hard.
Yeah, so now what diff3, the generic diff3 is doing is somehow aligning edits in a naive way. So essentially, just whenever you happen to have a misaligned insert, you just insert an operation, and that will actually won't cause any conflict. And the motivation for this to do that is, as I said, no operation doesn't really change neither the source or the target object, and guarantees not to introduce a conflict. And I think that the point here is that we could trigger a conflict, but there is no ground at the same time, in the general case at least, to say argue why should we have a conflict. Maybe things, I mean, in sort of an optimistic way, we introduce an operation there, knowing that this will actually not trigger a conflict. So I don't have a sure answer about this. So what would be the best way? I'm sure that it would be interesting to experiment and see. There could be several, as also you mentioned, you could try to see how bad inserting can it go, like how many conflicts can you trigger, and instead how few how many can you avoid of these conflicts by the way you insert. And I think that this should be some sort of evaluation that will guide us into with some concrete cases to see what should be the best option, the best way to insert an operation and to align things.
Okay, so yeah, all right. So the other thing that you're saying is that if you align in the wrong way, you might get edit scripts that don't type check. Yeah. And actually, one other thing that I think you're saying in your paper is that if a merged edit script contains a conflict, then you always consider it as not type checking. So this is actually something that I would encourage you or someone else to work on, because the way I see conflicts really is conflicting documents are a superset of OK documents, and a conflicting document is a representation of multiple documents, multiple possible documents it could be at the same time. And typically, there are standard ways of resolving conflicts, something like I want to pick one version and disregard the other, I want to pick the other version and disregard the first, or actually the data type I was operating on was not fine-grained enough, and morally there isn't even a conflict, and there are some sort of finer-grained merge I can perform. And so in principle, I would hope to have a system which allows me to resolve conflicts and still be in a type-safe way, right? So that I have a representation of a generic conflicting document, and I have certain operations that are provided by the library or the tool that I can use in order to resolve conflicts, and I'm guaranteed that if I do this resolution, I end up with a type correct conflict, with a type correct document again. So I would really hope that this sort of generic approach to conflicts would not just give up at the level where you reach a conflict and say I cannot say anything about the types at all anymore. Right. Do you want to say something? Otherwise, I would use this to open the floor to other questions. So
yeah, I would say that maybe a better distinction would be that there are maybe two kinds of conflicts. So when you, for instance, have conflicting sort of basic ground values, like just two integers, they are different. well, in this case, it's not really. In this case, the conflict doesn't involve like types at all, because it's just that you have two different values and you have to choose one. But in other, what we have now is that we can actually update nodes which could contain constructors, and therefore, depending on one constructor or the other, you could expect different subtrees. And in this sense, this could actually. That's why I consider this as ill-typed, because there is no unique type, because of the choice of different constructors could require to read up the rest of the script in different ways.
I completely get that this becomes very, very complicated, but this is all the more reason that I want to have some support, right? Because it actually becomes really hard in the presence of these sort of structured conflicts to end up with a type correct thing again. So that's all the more reason for me that I would like to have some sort of automated support. But okay, perhaps we can take some more questions. Yes? Yeah.
Well, I have a little problem understanding how you get from two values to the edit script in some examples. So, for example, if you have a list of the same repeating values, and you make this list longer by making it longer with the same values, how do you distinguish between just changing the empty at the end of the list with a non-empty list of length 1, or by appending the element in front? So the scripts can distinguish it, but yeah.
Right. So I didn't talk about this because actually for diff3 this doesn't really matter. So it's a sort of related but orthogonal problem that is diffing, which is what the generic diff work that you worked on is actually about. So ideally, the better the diff script is, the better sort of embedding it will find. So like the more clear explanation for the changes that you make. And normally you use some sort of minimization problem. Like for instance, in the text line-based diff3, you try to minimize the length of the edit script. When I did this for diff3, I had to take into account that updates actually somehow are preferred to delete and insert, which is because then you have more clear, a precise, a more clear view about what is changing. But this is still open. You could find different sort of metrics.
I think there was a question over there. Yeah.
I thought this is more like operation that it seems to be the conflict document is just one where you turn each sum into a product of optional subtrees. Because that's the only part where you can have a conflict, right? Wherever you have a sum in your ADT.
I'm sorry, I didn't understand the question.
So the only point in your ADT when you can potentially have a conflict is wherever you have a sum, right? If it's a product, then you need to go on and
okay.
So the conflicted document seems to me that it's something where instead of just a sum, you have a product of all the possibilities, except each of them is optional because you might not cover all. If you just have two, then you're not going to have more than two branches covered, right? But it's still just turning the sum into product seems to me to be what a conflict. How you represent a conflict? Not the single conflict, but the conflicted document.
Right. Okay. So it's about how would you. So basically, it would be about how would you somehow handle a conflicting document, and that you would somehow try to hold on the conflict in some sort of subpart. Well, yeah, I would say that this is possible. I mean, I think so, but I didn't really think about doing this. But it's a good point. Thank you.
I think there was a question about Jeremy.
Have you connected this to work on bidirectional programming and lenses in particular? So a lot of these things about alignment are addressed in the lens community. The question about different edits, different deltas that might lead to the same difference is well explored in the bidirectional programming community.
Right. Yeah. So yeah, the depending on the way you essentially align the objects, you can get different edits and therefore different configs. What I did here is, so this work is for algebraic data types. So it works on very structured, as I say, structured and ordered trees in the specific. Actually, this diff3 algorithm, for instance, has poor performance on unordered collections, for instance, like sets, because the way a set is structurally represented in data type doesn't really match with the semantical meaning of a set. So two sets could have different, in a balance tree, for instance, could have different, end up having different forms, different shapes, but still be the same. So this is this part is where this work is weak. So that's the point where we would need to look into more like how to handle unordered data, and maybe work on lenses could really help there.
Yes.
Okay, I think I wanted to stop there then.
Yep.
Thank you very much. Thank you.